Hello everyone. So the next wee topic in our light and sound topic is on refraction. Now, refraction, just like reflection, is something that you will have come across before, but you might not have heard the word before, like you've heard the word reflection. Refraction is something that you at home can see right now, if you want. So if you get a glass of water, and I've said put a straw in here, okay? Doesn't need to be a straw, a piece of cutlery will do, anything like that. And you put it into a glass of water at an angle and just have a little look at what you can see. Okay, you should see something like this. Okay, so this is a wee example where the person has put water in and then oil. So it's a little bit different than what we've done. But what you should see is when it's at an angle, so like when it's over here, you should see that the piece of cutlery or the straw or whatever looks like it's bending. Okay, you can see it here as well. Okay, it looks like the spoon is actually cut in half, and vertically here you can see that it looks like the colours have sort of inverted. And I just like this wee example, so I put it in. Okay, if you've ever been to an aquarium or anything like that, I'm sure you've probably actually seen this, but maybe not thought about it. This phenomena is called refraction, okay, and it's all about when light travels from one medium to another. Okay, medium, I just mean air to water in all of these examples. Okay, so when light travels from one material to another, it actually changes direction some of the time. Okay, and we're just going to explain why that happens. So it happens because light travels at different speeds when it moves through different materials. Okay, we've already learned that light travels extremely fast. Okay, it travels at 300 million meters per second, but that's its speed in air. Okay, it actually travels at different speeds, still extremely quickly, but it travels at different speeds when it's in different materials. Okay, and because this happens, this weird phenomena of it sometimes changing direction happens. So to explain how this happens, we are going to use an extremely amazing analogy of a car. This is a car, believe me, moving from concrete into mud. Okay, it's just quite a nice visual. So imagine we have our car traveling at sort of this angle. It's on concrete and it's moving towards the mud on the other side. Now, when it reaches this boundary between the concrete and the mud, there's one wheel that is on the mud and the other three are on the concrete. Now, the wheels on the concrete are going to be moving no problem, okay? But the wheel in the mud is going to have a hard time moving. Okay, so what's going to happen is that if this wheel isn't really moving as quickly and these wheels are moving quickly, the car's actually going to kind of spin around a little bit. If you've ever had a shopping trolley that's one of the wheels is a bit dodgy, you'll have experienced this. The trolley will start kind of moving like that, moving a bit weird. Okay, so this is what's happening to our car. It started to move that way around a little bit. Now both of these wheels are in the mud, so it's now just going to start moving along a straight line again. But because it's now in the mud, it's going to be going slower. Okay, because well, cars aren't meant to be driven in the mud. Okay, it's going to be going slower. So this has happened. It's gone fast in the concrete, okay, but then one of the wheels has gone onto the mud, okay. Because only one of the wheels has done this, the other three are going fine. Okay, it does turn a little bit, and then when it turns a little bit, it goes onto the mud fully, and when it's on the mud, it's going slower, and then it just travels off in a straight line again. Now, we're going to take this image and we are going to replace the car, the concrete, and the mud with light, air, and glass. So we're going to change the concrete with air, because just like how the car travels quickly on the concrete, light travels quickly in air. We are going to replace the mud with the glass, because just like how the car traveled slower in the mud, the car travels slower in glass. And we're going to replace the car with light. Okay, and this is what happens when light travels from air to glass. It bends like this. And we call this bending of the light refraction. Okay. Now, when we looked at reflection, we had to learn a few different names for our angles of incidence, our normal line and things like that. All of those things actually appear in refraction as well. So let's just have a wee look at how we sort of draw this out a little bit more scientifically. So if we were drawing a ray of light going from air to glass, what we'd have to do is draw in a normal line. So this normal line, just like in reflection, is a dotted line. And you see in reflection, it was always at 90 degrees to the mirror. In refraction, it is at 90 degrees to the boundary between air and glass. So this boundary here is vertical. So that means our normal line is horizontal. Now, unlike reflection, the normal line stopped at the mirror, okay, because the light wasn't traveling through the mirror, the light was bouncing back, so we didn't need to have a normal line here. But in this case, the light is traveling through the boundary, so we do need to have the normal line on this side of the boundary and on this side of the boundary. So we have our boundary and we have our normal line at 90 degrees to the surface of the boundary, okay? And just like in reflection, we have our angle of incidence in here. Now, again, I like to remember the angle of incidence because it is going in to the boundary, okay? So it's going in to the boundary. It hasn't been refracted, going into the boundary. So it's the incidence, the angle of incidence. Again, shorthand is just an angle symbol and an I. And then here, slightly different. It's not the angle of reflection this time, it is the angle of refraction. Okay, so please be careful that you don't get reflection and refraction mixed up. I do realise that they sound quite similar and I'm having to use so much of my brain to make sure that I don't say reflection when I mean refraction. So yeah, please just be careful to get those the right way around. So this is the angle of refraction. Again, just angle symbol and an R for its shorthand. And this is the angle after the light has been refracted. Okay, and note that these angles are both between the normal line and the ray of light. Okay, between the normal line and the ray of light, just like in reflection. Okay, angles of incidence and angles of reflection and refraction are always measured between the normal line and the ray of light. Okay, so this is when we would usually do a little experiment. So what we'd get is a block of glass, or a block of perspex actually is, okay, and we would put it on our jotter and we would get our ray box out. So our ray box, remember I did mention it in the last video as well. Ray box is just well, it's a box that gives off light, okay, and we can put a little filter on it so it just gives off like a beam of light. So we have our ray box here and we shine a beam of light onto an angle like similar to this, and what we would do is just observe what happens to the light as it travels into the block of glass or perspex and then back out again. Okay, so we're actually seeing the light go between two boundaries. We're seeing it going from a boundary of air to glass, but then as it travels through the glass, it's going to reach another boundary between glass and air. So we just kind of see what happens. Now, this is what you should see. Okay, so the light comes in here, okay, and then it slightly bends, okay, like this. And then at the second boundary between glass and air, it bends again. Okay, so there's actually 2 points of refraction here. You're seeing it being refracted here, okay, when it goes from air to glass, and you're seeing it refract here when it goes from glass to air. Okay, we'd do the same experiment with a triangular block of perspex. So we would just get the triangular block of perspex, we would shine our ray box again at an angle similar to this, and we would see what happens here. So I've got a few wee pictures here to show you. So I want you to just actually look at this one first, because this one just shows what happens in the most sort of simple way. So again, just like in our rectangular block, we see that the light changes direction twice. We see that it refracts here and refracts here. Okay, so from light to glass and from glass, sorry, light to glass, air to glass, and glass to air. Now, notice that this boundary is at a bit of, well, it's not vertical or horizontal, it's at an angle. Okay, so just remember that if you were drawing in your normals, if we come down here, okay, this is a bit small, but this is a dotted line here. Okay, just note that this dotted line is still at a 90-degree angle to this boundary. Okay, see that? And then when the light travels through this glass block, it gets to this boundary. And this boundary is at a different angle to this boundary. See, it's a different direction, yeah? So that means that the normal is also, the normal that they've drawn in is also at a different angle to this one, because this normal is at 90 degrees to this boundary. Okay, so just note that. This is quite a hard example, but I just wanted to show you how the normals work. Okay, so this is what you would kind of see, okay? But something weird does happen in this experiment, in that actually the refracted ray of light actually disperses into what we call a spectrum or a rainbow. Okay, and we'll discuss a little bit more about that later on. And I mean, if you're really keen, join me in higher, and we'll look at it in a little bit more detail there, why mathematically it happens. But this happens, so a bit of white light comes in, okay, or normal light comes in, and then it actually splits up into all the colours of the rainbow, and we call that a spectrum. But it still follows this these directions. It still kind of changes direction like that. Okay, so blue boxes mean a note. Okay, either myself or Mr. Patterson has discussed this with you, that if obviously you don't have a notes jotter, if you don't have your old S2 one, then you can just write it out on paper, that's fine, or you can make a Google document for all your physics notes. If you do make a Google Doc, please can you name it something sensible and not just leave it as untitled document, because I've seen too many people with their drives just full of untitled documents and then we never actually find anything. So yeah, just name it something sensible, or put it in a folder or something like that so we can actually find it. Anyway, off topic a little bit. Right, so this is what happens when light goes from air to glass. Okay, and what we say is, when light travels from air to glass, now when I'm saying air to glass, I'm just meaning a less dense material to a more dense material. So usually what we deal with is either air to glass or air to water, or obviously water to air or glass to air. Those are the examples that we look at most. What we say is the light bends towards the normal, okay? Because you can see how this ray of light bends, so it's actually closer to this normal line. meaning that this angle in here is smaller than this angle in here. Okay, like so if I extended, I'll do it in a different color. Oh dear, I'm gonna have to freehand this. It's gonna be a nightmare. Ooh, oh dear, it's supposed to be a straight line. Oh, anyway, that'll do. Yeah, so if I extended this straight line, not that it's a straight line, it would go off in this direction, okay? But as it's been refracted, okay, this line has refracted towards the normal, so it's actually now closer to this normal line, okay? Now, when we have a light moving from glass to air, okay, again, we have our angle of incidence and our angle of refraction. This is our angle of incidence because it is going in to our boundary, and this is our angle of refraction because our ray of light has been refracted, again, between the normal and the ray of light, between the normal and the ray of light. From glass to air, the light bends away from the normal. Okay, so I'm going to attempt to draw a straight line again, bear with me. Okay, so if this ray of light here just continued, that was a little bit better, continued off at in a straight line, the light would just do this, okay? But it hasn't, it is refracted, okay? So our ray of light has now moved up a little bit, is moved away from this normal line, okay? And then when our light travels at exactly 90 degrees into a glass block or into water or something like that, it won't actually change direction. Okay, so if light enters or exits an object at 90 degrees to its surface, it will not change direction. Okay, this happens because if you think about it, if light goes towards the normal from glass to air, well, if it's already on the normal line, it can't get any closer to the normal. Okay, so this just happens. It just goes straight through. No change in direction. And just a little reminder here, an angle when we're dealing with light, so refraction, reflection, is always measured from the normal to the ray of light. Please remember that. Okay, so these are just a few wee pictures I've put up just to see what it looks like when light travels from air to glass and then travels from glass to air all in one swoop. Okay, so we have the incident ray going in to our first boundary. Our normal is drawn here. Please note that there are two normals because there are 2 points of refraction happening here. We have our angle of incidence and we have our angle of refraction. But then we also have a second angle of incidence and a second angle of refraction. Well, because, as I said, there are 2 points of refraction. Okay, it's going in, it's been refracted. It's going in, it's been refracted. Okay. Now, as I said previously, please remember that your normal is always at 90 degrees to the surface. That means that the normal doesn't particularly need to be either vertical or horizontal. Okay, obviously it is vertical here and it is horizontal there, but it could be at like a weird angle like this. So if this is my boundary, then my normal has to be at 90 degrees to that boundary. Okay, so coming back to the first wee images that we looked at, like the spoon and the cup, and seeing that it looked like it was bent or broken up. Why does that actually happen? Well, this is just a sort of simplified picture of why we perceive things to look like they've been like bent when they're in water or whatever. And it's because our eyes always perceive light as traveling in straight lines. Okay, so this is the actual position of the pencil, obviously. Okay, now the light from the pencil edge is coming up to the boundary of the water-air boundary, and then it is being refracted into our eyes. But these rays of light that are reaching our eyes, we perceive them as being straight, okay? So we're seeing these, but we assume that it's come from this point here, okay? Because we always think it's traveling in straight lines. So that's why we see the edge of the pencil here, okay? Because the light that we see that is coming into our eyes has traveled in this direction, okay? So that's why we perceive that the pencil or the spoon or whatever has been bent. Okay, just a little summary. Please remember that refraction is caused because light travels at different speeds in different materials, and this can cause the light to change direction. Okay, remember it doesn't always change direction. Okay, it doesn't change direction if it was entering or exiting the block of glass or whatever at a 90-degree angle. Okay, so if you're ever asked for the definition of refraction, this is it. Okay, refraction is caused because light travels at different speeds in different materials, and this can cause the light to change direction. Okay, light always slows down if it goes into different materials. Okay, the quickest it can be is in air. Okay, so if it goes into glass or goes into water or whatever, it does slow down. Okay, still very fast, but it does slow down. Okay, that is refraction.